4 of chapter 6 is all about rational exponents. The word rational implies fraction, and exponents are those numbers in the air. So you're going to have fractions in the air. Quick key concept for you. Anytime that you have a fractional exponent, it can be rewritten as a radical. And I also want to point out that this one right here just changes the location of the parentheses. So it doesn't matter if you root first and then take an exponent, or if you take an exponent and then root. So either way, you should still get the same answer. I'm taking a look at the first set of problems. They want you to write the expression using a fractional power and then simplify. So again, just like this key concept right here says, fractional exponents are really roots, in which the denominator of the fraction is the index. And so in letter A, the cubed root of 125 can really be written as 125 to the 1/3. And the cubed root of 125 is 5. For most students, it's easier to find those roots in radical form and not fractional form, but they are still equivalent. In letter B, the 4th root of 16 can be rewritten as 16 to the 1/4. The 4th root of 16, or the 16 to the 1/4, is really 2. Letter C, the cubed root of 27 can be rewritten as 27 to the 1/3, which is just 3. Letter D, the 5th root of 32 can be rewritten as 32 to the 1/5, which is just 2. In letter E, the 6th root of 64, this one's a little higher, but it's 64 to the 1/6, and that's just 2. And letter F, don't forget that if the index isn't written, it's understood to be a 2, so this is the same as 36 to the 1/2, which is just 6. Just like we can go from a radical to a fractional exponent, we can go from a fractional exponent to a radical. This is extremely helpful when the denominator of the exponent in the air is the same. So because that 2 matches that 2, it's a really big hint that you're going to want to change these into radicals. 7 to the 1/2 is really the square root of 7. And this 7 to the 1/2 is still the square root of 7. The square root of 7 times the square root of 7 is the square root of 49, which is just 7. So being able to change exponents in the air that are fractions into radicals helps us solve them a lot faster. In number 2, because they both have a denominator of 4, I'm going to change this to the 4th root of 5 times the 4th root of 125. The 4th root of 5 times the 4th root of 125 is the 4th root of 625, which according to your list is just 5. In number 3, because those 3's in the air match, I'm going to make this the cubed root of 3 times the cubed root of 9. Because the index match, I can make that the cubed root of 27, which is just 3. Just a quick refresher from Algebra 1. Anytime you're multiplying something that has an exponent and the base is the same, in all of these they have exponents and all of the bases match, you keep the base and add the exponents. So an x squared times an x cubed is an x to the 5th, because 2 plus 3 is 5. 8 to the 4th times 8 to the 6th times 8 to the negative 2nd is 8 to the 8th, because 4 plus 6 minus 2 is 8. 2 cubed times 2 squared equals 2 to the 5th, which is the same as 32. And 5 to the 6th times a 5 to the negative 2nd is 5 to the 4th, which is the same as 625. So you add exponents when multiplying. A quick reminder that anytime you have a fractional exponent, the number on the top is the power, and the number on the bottom is an index. Seems kind of silly, but I had a student once who remembered this using the acronym bow tie, which stood for the B was bottom, and the O was out. So the bottom number stays out, while the T for top stays I for in. So the bottom number here is a 3, that stays out. The top number here is a 2, that goes in. Bow tie. So taking a look, they want you to convert each exponential expression into radical form. So in letter C, the cube, or C to the one, or number 1, C to the 1/3 is the cubed root of C to the 1st, which is just C. The 3 stays out, the 1 goes in. In number 2, a to the 2/3 is really the cubed root of a squared. Number 3, a to the 4/5. The 5 will stay out, and the 4 will go in as a power to a. Number 4 is a little trickier because it's given to you in decimal format, so take a couple steps to simplify that. 0.2 is really 2/10, which reduces to 1/5. So what I really have is the 5th root of y. You can change decimals to fractions first and then simplify. In letter B, 1.5. 1.5 is 1.5, which is the same as 3/2. The calculator will change a mixed number to an improper if you need it to. So this ends up being the square root of b cubed. Now, this is really important, something you're going to have to keep an eye out for. Anytime the top number, in this case is 3, is larger than the bottom number, you can simplify it. Back a couple of sections ago, we rewrote this as a b squared b, because this came out as a b, leaving me with the square root of b underneath. Now, I can simplify it, I can reduce it. Keep in mind you did start even and end odd, so you need absolute values around the b out front. Probably the trickiest kind. Just keep a lookout. If the top number is larger, you do need to take it a step further. Oh my, that's really transposed. Sorry about that. Let me see what I can do to fix that. These are okay. I mean, they're kind of weird looking. This one should be the cubed root of a squared. This one, though, is really hard to see. They kind of put it on two different lines. This ends up being the square root of, not an a, it's an x. Square root of x cubed, which should be rewritten as an x squared x, which is the absolute value of x times the square root of x. And then this one needs to be fixed as well. You can see it. This is the same as the 5th root of s to the 5th and s squared, which is s times the 5th root of s squared. All right, they want us to take the radicals and make them exponential form, so it works the same way. Anytime the index isn't there, it's understood to be a 2, so that does happen in number 1. And remember that that number inside is the top and the bottom is the index. So this is really a to the 5/2. In number 2, that 3 becomes your numerator and the 4 is your denominator, x to the 3/4. I talked in the very beginning about that second key concept, in which the placement of the parentheses around the whole thing just means that it doesn't matter which one you take first. This is the same as b to the 3/5. This one is y to the 4/3. I'm still taking that power and putting it on top and the index on the bottom. Number 5 is trickier. In number 5, this 3 goes to both the y and that 3. So I would start by making this the square root of 3 cubed and y cubed, which means both of these have an index of 2, so do them separately. That means 3 to the 3/2 and y to the 3/2. They both have the power and they both have the index. I've seen places rewrite these as 3y to the 3/2, but I think it's probably in your best interest to keep this one. So again, in this last one, I would probably take this a step further and make it this instead.